Hi, welcome to Study with Rishi. Today we are going to talk about Hashmap. Hashmap being one of the most frequently asked Java interview question, yet people struggle with it. There are so many students who are still confused about Hashmap and its working. Today we are going to learn about several different aspects of Hashmap. The first is we'll start with what is Hashmap, then we'll move to why do we need Hashmap actually, then what is the internal structure of Hashmap, how a hashmap grows, what is the time complexity of storing the data and retrieving the data out of hashmap, and then in the end we will also learn how to use custom objects as key in hashmap. Yeah, so let's start with what is hashmap. Hashmap is basically a key value pair data structure. That means inside it we store a mapping of key and value. It contains only unique keys, but it also allows one null key to be stored, yet it allows a number of null values to be stored inside it. It's non-synchronized. It does not maintain insertion order. Its initial capacity is 16 and the load factor is 0.75. We will talk about this initial capacity and load factor in detail in the end of the lecture. So as we said, it's a key value pair data structure. Let's look at its internal structure. So basically, a hash map is an array of buckets. So you are looking at the buckets and I'm making an array out of it. So each bucket is actually a linked list of node. So these are the buckets. This is the array of buckets. Each bucket is at some index. That means every element of array is a bucket. Inside each bucket, we will be storing the nodes, basically a linked list of nodes. And we will talk about why do we need a linked list and why just having one single node is not sufficient. Initially, till Java 7, the linked list was used as a data structure. In Java 8, now they are using a balanced binary search tree for better optimization. Each node is basically having four different properties. The first is its hash code, second is its key, third is its value, and fourth is a pointer to the next node. So this is one of the most important part of understanding hashmap. This particular structure is which should be clear to everyone who needs to learn, who wants to learn about hashmap. If you look at closely at a bucket, you will see that each bucket is basically a linked list as we just talked. And each node then will be having four different properties. So we have just covered what is hashmap and what is the internal structure and somewhat what is the internal structure of hashmap. Now we also need to look at how to store and retrieve the data in this structure of hashmap, and that will be connected to the time complexity of storing and retrieving the data out of hashmap. So when we say when do we need hashmap, we need hashmap in situations when you need to store and retrieve a pair of objects in constant time complexity. Remember, pair of objects in constant time complexity. So now let's look at how the data is stored in hashmap. Right. I'll copy the structure, the internal structure of hashmap here, and I'll talk about how a particular object, let's take a string as an object, be stored inside the hashmap. Let's say our array of buckets, that means our hash map is having 6 different buckets, 6 different indexes, and we need to store a string and object pair, object being an employee or anything else. It's a custom class object. It could be anything which is a value. It could be anything which can be stored inside a hash map. We will use the put method of hash map. So put will have 2 parameters. The first would be your key, which is a string, and second would be your object. Let's take a custom class object for now, and we will see how we can store other types also. So what is the first thing which we require while putting something inside a hash map? We require a location. A location here means index. But how to compute this index, right? We need certain functionality which can give us back the index when we pass them our key. So each object, be it a string class, wrapper class or custom class object, it comes from object class. Okay, and object class gives us 2 different methods. One is hash code, another is equals. These 2 methods are very important if you want to learn about Hashmap. Between hash code and equals, there is a contract that they both needs to be in sync. If you are overriding one, then you need to override the other appropriately. Just remember, if you incorrectly override these 2 objects, you might break the functionality of Hashmap. Hashmap might not work intermittently. So you need to be very careful while using and overriding hash code and equals. Now let's talk about hash code method first. Hash code method will give us a location. That means it will give us an index. That means it will give us an integer value, right? So the structure of hash code will be public int hash code, and it requires to perform certain functionality over an object. Okay, so we might not require to pass an object as a parameter inside hash code, but for the simplicity of understanding, I have just passed it inside the parameter. Otherwise, it can take the object with this keyword, which actually refers to the current object. It's a very simple implementation where eventually you will be returning an integer out of h method, which could be an hashing method. Let's just take it as a black box that it is a method which is returning an index, an integer. So we have an index which is basically a hash code, and we are using AND operator with n-1, n being the size of hash map. This is used so that our index does not go out of bound for the hash map size. So we go to the location now. Example, if you take Rishi as a string and you compute its index, that is its hash code, and it comes as 3, so then it will go to the third index, third bucket. Then inside third bucket, it will traverse over the linked list present. If there are no elements, it will just create one element. If there are elements, then it will use equals method to see if the key Rishi is already existing or not. Right? This is how hash code and equals are working together. So if there is an already existing key, then it will replace the value. If there is no already existing key with Rishi, then it will store the value. If you're not able to understand, go back to the starting of the video and revisit the video. But hey, why do we need list in first place? Does it mean that more than one objects can come to same index with hash code integer output? What do you think? The answer is yes. Yes, more than one objects can have same hash code, and having same hash code means that they all will be coming to same index because the hash code integer output will be same. and this is known as collision. How do we resolve this collision while storing inside Hashmap? Well, we have made the linked list, right? So each time a collision occurs, the same key on which the collision has occurred will go to the location, the index, and then it will store itself or replace itself in the same linked list of that particular bucket. So like this, let's summarize. So like this, if two objects are having same hash code, then if they are not equal using the equals method, or if they are equal using the equals method, different functionality will be performed. If they are not equal using equals method, then a node will be added in the linked list. But if they are equal, then the value will be replaced. This is the point where most of the students get confused. So this is the difference when and when not the value will or will not be replaced. So equals method actually tells Java that these two objects are equal to each other, right? But what is the default implementation of equals method? It basically compares the memory references. So as I talked earlier, that hash code does not require a parameter to be passed. It can just take reference of this keyword to refer to the current object. So in the signature of hash code, there is no parameter. Now let's come back to the equals method. What is the signature of equals method? Well, it will return a boolean. You just need to know true or false, whether two objects are equal or not, but it needs to compare two objects. Hence, one object will come with this keyword, another we need to pass in the parameter, right? Let's say the object we are passing in the parameter is a string. How you will compare two objects which are string? We'll use equals method, right? It's already there. This is one of the overriding way of equals method. There could be more depending upon your own needs. So using hash code and equals, we were able to store the data inside the Hashmap. The default implementation, as I talked earlier, checks if two objects are coming from same memory reference or not. If they are coming from same memory reference, that means they are same object. If they are not, then they are not. But what is the downside of this? We will see when we will talking about custom objects as key in a Hashmap. Now let's talk about the complexity. See, the complexity of average case is constant, but in the worst case, it could go O of n because we need to traverse over the linked list. It was till Java 7. Java 8 optimized it O log base 2n because now they are using balanced binary search tree. Hey, now we have stored, but how to retrieve the data, right? We will retrieve the data in the very similar fashion in which we store the data. We will take the key in the get method, right? And the Rishi string is basically our key. We will compute its hash code. Hash code will give us index. We will go that bucket on that index. We will traverse over the linked list. We will compare objects using equals. Equals will match if the key which we are using to retrieve the data is already present or not. If it is already present, then it will say here is your value. If it is not, then it will return, hey, there is no data which you are trying to retrieve. So we have talked about a number of items here. Now let's talk about how Hashmap grows. But before we talk about how Hashmap grows, let's talk about, can we use custom objects as our key inside a Hashmap? This is one of the frequently asked questions when people are having a discussion in Java interview. And the answer is yes, you can have custom objects in Hashmap. But what is the catch? Let's talk about it. Let's say you have a class employee, which is your custom class, and it has an integer ID, a string name, and you want to store the data in such way that the key is basically an employee object and the value is the salary the object is getting. So let's say you have a new employee Mohan, and Mohan has a certain ID. Okay, this is the constructor of initializing the employee object. So you save it, but how would you save it? You will use put method. So this is the structure of your hash map, that you have an employee object and then you will have some string which is representing the CTC or the monthly salary or something like that. So while storing the data for the employee object, the hash code will be generated to retrieve the index. On that index, on that bucket, we will use equals to see if linked list already having this particular employee as a key, right? So looking at the example, let's say we have a hash map with employee and string. This we have initialized one object of hash map. In hash map, we say map.put, and inside put we put the object of employee initialized with the constructor R and 1 being name and ID, 10,000 being its CTC. This is how we have put inside the map. How to retrieve the data for this same employee? What we'll do map.get, and then we'll again make another object of the employee passing the same values R and 1. But hey, here's the catch. Equals won't work here. This is a different memory reference, right? And because we have not yet overridden the equals method and the hash code method, even though the internal values of employee are same, these are two different objects and they won't be equal as per equals method, right? So this is the catch. How to overcome this hurdle? To overcome this hurdle, we need to override the equals method and so the hash code method. Now let's see how to override the equals method and then how to override the hash code method. Question arises is, where do we override and then how do we override? We need to override the hash code and equals inside the custom class, which is employee here. The overriding strategy would be different as per the scenario. In this case, we assume that two different employees are same if they are having same ID, which is an integer. So let's say in this case how we will override the first the hash code, first the equals and then the hash code. So equals will take employee and it will compare it with this. So this dot id equals e dot id. Very simple. This is one of the simplest explanation. We will also override the hash code here just to make sure that both times the employee objects are coming to same memory location, same index location, and they are not going to different index location, in which case the hash map may not work in some cases, right? So now when getting the data map.get, it will compare using the equals overridden equals method, and because two different employee objects will be having similar ID, they will be equal and the data will be retrieved. Now let's talk about what is load factor, right? Load factor is basically a threshold after which size of hash map will increase to accommodate incoming data. Size of hash map will be increased by 2. Initial capacity of hash map is 2 to the power 4, which is 16 elements. Load factor which is there is 0.75. So till 12th element, which is just before 7.5, it will be 16 as size. But as soon as the 30th element is stored, size will be doubled. So 2 to the 4 into 2 becomes 2 to the power 5, which becomes 32. And so on. Similarly, when the more data will be coming, the size of hash map will be increased. So load factor decides when to increase the size of hash map. Size means number of buckets inside the array. So we have covered all the questions of which we talked in the beginning of the lecture. You are watching Study with Rishi and this is Rishi Prakash Khandevla. Well, Rishi Prakash is my name and Khandevla is my village name. So in case you liked the lecture and I was able to make you understand how Hashmap works, then please subscribe and share to the channel. And if still there are doubts, please leave your doubts in the comments. I'll make sure that you understand Hashmap perfectly. Thank you.